Okay, we're live. Okay, so we're doing section 4.5, which is a mix of exponential and logarithmic functions. So all that stuff that you were learning before is for this section. So that means, even though you had a test on it Thursday, I hope you haven't forgotten it already, because now we're going to put it to real good use, okay? Those were just exercises to get us to here. Okay? So 4.5, exponential and log equations. Okay? And you guys still want the light on, right?
Yeah.
Okay.
The camera needs to focus.
Yeah, it does have a focus. I don't know how to fix that. All right, so solve 5 to the x equals 125. Okay, so we'll start with hopefully an easy one. Okay, Bailey, you're going to volunteer because you want the easy question?
Yes.
Okay, that's good. So how would you solve that? You just know the answer is 3. Why is the answer 3? 5 times 5 is 25 times 5 is 125, and this can be written as 5 to the third equals 125, so therefore x equals 3. Okay? All right, so that works out. What if I said 5 to the 2x equals 5 to the x plus 1? Yeah. How would you solve that?
Would we transition it into a log-based equation?
Well, since these are the same base, that's really nice, isn't it? That would just mean that this exponent would have to equal that exponent.
Okay, so just
That would be really easy to solve, right? So therefore, Julia, take it away.
Okay, so you just divide, or like 2x equals x plus 1, divide out the 2.
Nope.
Oh, sorry.
Subtract the x.
Or the x, oh my
I shouldn't call on you so early in class, huh?
goodness.
Okay, I'm left with
X equals 1.
x equals 1. Should we verify that that's the correct answer? Okay. 5 to the 2 times 1, does that equal 5 to the 1 plus 1? 2 times 1 is 2. 5 squared equals 5 squared. Yeah, that's a true statement. I don't even have to multiply that, but I could. Hunter, 5 squared is? Okay, all right, that's good. That was too easy. I'm still doing it.
You sure that's
All
not
right.
one of the questions on the test?
Yeah, I should put that one on there. Yeah, it's not too bad.
slow hanging fruit.
All right.
Yeah.
Okay, so this is where the book gets a little bit tricky here. What if I said, let's get with a hard one now. What if I said 3 to the x plus 2 equals 7? That one doesn't look quite so easy. Okay? Now, I'm going to do 2 answers. I'm going to say find, or 2 questions. Find the exact answer and find an approximation. Okay? If I say find the exact answer, guess what that means? Can use your calculator.
What? You can't?
If I say find an approximation, what does that mean?
That is correct.
You can use your calculator. Which one do you think I'm going to ask for?
Approximate.
Exact answers. Yeah. Okay? Jackson, how would you solve that?
So you gotta get the bases the same.
Can you get the bases the same?
Yeah, I don't know.
No, can't. That sucks.
Second?
That sucks, right?
Yeah, it's kind of not very nice.
Yeah, we can't use any of those nice techniques that we used before because I can't get 3 in base 7 or 7 in base 3 easily.
So.
That's a good first step, though. You should try to if you can.
So take a log of both sides, because then you can.
Okay,
do
which
X
kind of a
plus
log?
Huh?
Which log?
2. Let's do ln. Would that
ln?
be easier?
Yeah, you could either do ln. So the most common would be the ln, or it would be the base 10 logs. But I could do a base 3 log or a base 7 log too, just for fun. But those aren't easier.
Yeah, let's do ln.
Okay, so the idea was we're going to take the ln. Maybe I'll use a different color on that so you can see that's different than the original problem here. Okay, original problem is 3 to the x plus 2. I'm going to use black. I'm going to take the ln of both sides. What does that allow you to do?
X plus 2 can go into front.
You can pull this with that rule that we learned on the last test, and I'm going to be left with x plus 2 parentheses, right? Times the ln of 3 equals the ln of 7. Now we need to solve for x.
So divide by ln of 3 and then add.
So if I divide by the ln of 3, that's going to go away.
Yeah.
ln of 3. Can I cancel the ln's?
No.
No. Some of you are going to make that mistake. Don't do it. I'll smack your hands. Okay? Don't cancel the ln's. Can't do it. Okay? I'm left with x plus 2 equals the ln of 7 over the ln of 3. Can I keep going?
Subtract 2.
Subtract 2 from both sides.
There's your exact answer.
There's 2. So the exact answer, x equals the ln of 7 over the ln of 3 minus 2. Now, in the book, you'll notice they use base 10 logs. That's perfectly fine as well. So I don't care whether you use ln's or logs. My experience is people use ln's more often than logs, but either way. Okay? Now, how do you get the approximate answer? Caitlin?
The approximate answer?
Yeah.
Put it into your.
You type that into your calculator.
Yeah.
Okay, so either way, you're still going to have to come up with that.
When you mean the approximate answer, you have this overlay over the equal sign.
Yeah, so you'll say x equals approximately, and I believe, in fact, you guys should practice because some of you can't type this into your calculator properly. But the approximate answer, I usually say go to about 4 decimals. Negative point, yeah, I usually say go to 4, but the book has negative 0.228756. Okay, and it keeps going on. That's why we call it an approximate answer, because we've rounded that to, in this case, 6 decimals. Okay? So, this is the real answer. This is the answer you should expect to write on your test. Okay, I'm much happier with that than I am with this. Okay? All right, how about
So can't that be change of base formula simplified further? The ln 7 ln over 3, can't that just be like log log base 3 of 7?
So there is another way to do it, but I think it's actually harder to change the base.
Okay, so that's fine.
Yeah, this is better. But you can do this with the change of base formula.
We'll get extra points if we can change the base.
I'm trying to decide if I should even show you because it's actually harder to do it. You want me to? Who wants me to show you the hard way to do this?
No.
If that's good, we're not gonna have to.
This is the easier. This is definitely the easier
Well,
one.
I was fine, like after you have that answer, it's like, oh, then I can just put ln.
Here, I'm going to do it anyway. I think we got plenty of time. Okay. So if I had here 3 to the x plus 2 equals 7. Okay. And I want to use the change of base formula. Okay. Now, the 2 most common logs we can take are ln's and logs, but I could do the log base 3 or the log base 7. Log base 3 would make more sense, right? So if I take the log base 3 of both sides, okay, I can still pull this out, correct?
Yeah.
So I'm going to get x plus 2 times the log base 3 of 3 equals the log base 3 of 7. What's the log base 3 of 3? 1, so it just goes away. Okay? And then I get to subtract 2, and I get x equals the log base 3 of 7 minus 2. Can I type that into my calculator?
No.
Only if you use, who was it that had the illegal calculator? Was it you, Cameron?
It's not illegal if it's not listed on here. So,
But guess what?
yeah, no graphic calculator, it's not a graphic.
Guess what?
Same thing.
You have to get it back to here anyway to type it in your calculator.
So, but you don't care if we get the approximation. So we could
Well,
technically do that one anyway?
I'm probably on the test going to ask for that answer.
Okay.
So I really don't care if you get the approximate answer because I want that answer.
So if we do the change of base,
Once you
you'd
get
be okay
here,
with that answer too?
yeah, once you get here, you'd have to go to here anyway. That from here to here is the change of base formula.
So we will have to probably plug it into the calculator.
Probably will not have to.
Wait,
So
so
I might toy with the idea of getting rid of calculators because I want to make sure you guys know what you're doing. We'll see. I haven't decided yet.
I wouldn't.
how come that one's not an acceptable answer for an exact answer then?
This is an acceptable answer.
Oh, that is, okay.
Yeah.
Okay.
It's just you got to go there anyway.
For
So
the,
if you're really going to find out this answer, you'd have to go there.
got it.
Okay? All right, so let's go with another one here. 8E. Am I on camera? No, I'm not. 8E to the 2x equals 20. So I think it must be Kelly's turn. What do you think?
Since you're gonna be here, probably do Ellen.
Probably doing that one, but what's in the way? That 8's in the way, isn't it? How can I get rid of that 8? Divide by 8. Okay, so if I divide by 8, that's going to go away. I'm left with e to the 2x equals 10 over 4, which is 5 over 2, correct? Now what?
And then do Ellen.
Take the ln on both sides. And what can I do with this? Pull it out
Or you
front.
can move it on that side.
Which is,
Yeah,
yeah.
sorry.
And then the ln of e is 1. So this just becomes simply 2x, right? Equals the ln of 5 halves. Or 2.5, I guess. The one thing about this is you can write this a lot of different ways. Then what?
Divide that by 2.
Divide by 2. So x equals the ln, sorry, that was not supposed to cross out.
Yeah.
2.5 divided by 2. So that's one possible correct answer. I could have also, when I got to this point here, I could have written this as the ln of 5 minus the ln of 2, right? Equals 2x. Do you see that?
So you don't care.
Divide by 2. I get x equals the ln of 5 minus the ln of 2 all over 2. Do you understand that those are the same answer?
Yes.
Okay.
The first one's cleaner though.
The first one's a little cleaner, yeah. But that's what makes great in your test, because some of you are going to do both. And they'll be like, oh yeah, those are both correct. Okay? Okay, here's another fun one here. E to the 3 minus 2x equals 4. Okay, how do I solve this one? Dino, it must be your turn.
Did you do ln?
Ellen, that sounds like a good idea. On both sides. What we'll do with this, the front, and I'm left with 3 minus 2x equals ln of 4. Okay, then what? Divide by? Not divide. Subtract 3, right? Subtract 3. Then I'm left with negative 2x equals 4 minus 3. You're adding in some extra steps. I'm trying to save you. Okay? Don't make that mistake on the test. Okay? Then what?
Then you divide by
Negative 2. X equals the ln of 4 minus 3 all over negative 2. Let me ask you guys a question. Hunter, is x equals 3 minus the ln of 4 over 2 also a correct answer or an incorrect answer? Yes.
Yeah, seems right.
Seems right? Willing to bet your grade on it? No?
I think it's right.
It is.
It is correct. Those are the same answer.
Doubled it. She
Okay.
asked for a name.
That make sense? All right. This is one of my favorite problems to do. You're supposed to groan when I say that. See the groan? All right. E to the 2x minus e to the x minus 6 equals 0. That's a good one. That feels like a problem for Niels.
It can't be. I'm gonna add 6.
Nope, that won't help. I think 6 would actually be a bad idea.
Okay, well then I would just do a natural log of all of them.
Well, the problem is you can't do a natural log across those places.
Should we factor that?
Factor it, that was good.
You still wouldn't move to the 6 before you factor?
I would not move to 6 because that would actually make factoring more difficult. Okay? You guys remember U substitution? I think this is an easier way to do factoring. You ever heard of U substitution?
Yeah.
Victor, what's U substitution?
You put U in for the U.
So I'm gonna let U equal to what? E to the x.
Yeah.
Therefore, what does U squared become? E to the 2x. Oh, that was slick. So now if I rewrote this as U squared minus U minus 6, that's easy to factor.
Nice.
Okay, and then what? This factors into factors of U squared,
U.
U and U, 6, 3 and 2,
Negative 3, positive 2.
negative 3 positive 2 equals 0. Now, U equals,
E to the x.
U equals 3, right?
And negative 2.
Or U equals negative 2, correct?
So.
Now I'm going to just substitute back. Okay, so this is here, e to the x equals 3 or e to the x equals minus 2. Now let me ask you a question. Is that ever a true statement?
No.
No, because
Can't have a negative.
if you were to graph this, it would look like, sorry, that's a straight line. This is a dashed line. Can it ever be a negative number? No. So that one goes away. Can't be negative ever. Okay, because you all remember how to graph, right? You'll never forget again, right?
Never.
Okay, so therefore, Niels,
So we could we can rearrange that to be the natural log of 3 equals x.
take the ln on both sides, the x comes out front, x equals
Say what? 1. Oh.
ln of 3. Does that make sense?
It doesn't make sense.
You were with me here, right?
Yeah.
U equals e to the x. E to the x equals 3. How do you solve that equation?
Oh,
Got that? Just make it a log.
I take the log of both sides. And the x comes out front, right? What's the ln of e?
Cancels.
1. So I'm left with x equals the ln of 3. Okay?
That's so random. Let's just throw a U
I
in.
told you that was my favorite problem for a reason, didn't I? Okay? If I put that on the test, you're gonna make it? You're gonna ace it? Dino's like, no way, are you kidding me?
it's more easy than that.
Okay?
I mean,
All right, that old U substitution, has it, besides Victor, has anybody ever seen that before?
yeah.
Okay. All right, so yeah, that's an old technique that we use. I could have, if I were super smart, I could have gone straight, I could have ignored all this and just left it there, but I think that's an easier way to see a factor.
So you could factor that.
I could have factored that into e to the x minus 3 and e to the x plus 2 equals 0. I could have gone straight there. But most of you don't think that way, do you?
Oh, yeah, no, that would.
And then you would have still said, yeah, it can't be negative, so that's going to go away. It can only be that answer.
Got it.
What does E represent again?
What does e represent?
Natural logarithm.
No, it represents a special number.
2.
Special number is, please?
I don't know.
Wait, where do we do that?
2.78.
It's just
2.7182818.
So you can do the substitution even if it's like 17 2x. So 2x minus 17 to the x minus 6.
17 to the 2x minus 17 to the x minus 6. Yeah, you could factor
It's
that.
like the exact same process.
It's the exact same process. I'd probably still do U substitution.
So any number to the 2x minus any number to the x minus 6 will equal 0.
Well, this is what I gave you. Yeah, I mean, you could factor it. You're being a little bit broad with that statement, so I don't know if I go all that way.
Well, I'm just trying to like understand that you.
Yeah, if this was your original equation, yeah, I'd let u equal 17 to the x and u squared would equal 17 to the 2x, yeah. Okay? All right then, how about another good one. 3x e to the x plus x squared e to the x equals 0. Now you're all thinking, man, I hope he doesn't call on me. Christian, what do you think?
Take L out of it to start, or you
I can't take that line because I got this plus in the way.
can you just subtract one to the other side?
I could do that. That would not be helpful.
Okay. Or is it anything like the one we did last time? Okay.
Yeah.
Okay. You gonna do the U stuff?
I don't need to use substitution, but is there anything I could factor out? I could factor out e to the x. Anything else? I could factor out an x e to the x, and I would be left with
Just 3 plus
3 plus
x.
x equals 0. Okay, now what?
Then divide the one side. I don't know.
Now I've got 3 factors here. Do you see that? What are the 3 factors?
X.
I've got a factor of x.
Okay.
I've got a factor of e to the x.
Okay.
And I've got a factor of 3 plus x. So any one of those could equal 0, and that would make that a true statement, correct?
Yeah.
So therefore, x could equal 0. That would be one solution.
Okay.
Or I could get e to the x could equal 0. Or
Then you just have x.
3 plus x could equal 0. Okay? And that's already solved.
And the other one would just be x equals -3.
Okay, so try 3, x equals -3. That would be a solution.
And then could you take the ln out of the middle one?
Okay, if you wanted to. So you want to take the ln of, what's the ln of 0?
Can't do it. Can't do it.
Can't do it, so therefore that cannot possibly equal 0. Why can't you take the ln of 0? Because it's undefined. If I were to graph that, it would look, e to the x would look like, I have an asymptote here, right? So it can never equal that because the asymptote. Does that make sense? Okay, so this middle factor will never be 0, so it's either going to be that one or it's going to be that one. So the answers are x equals 0, x equals -3, so that will never be 0.
Got it.
Okay? All right. Well, this is a good one. You guys are going to like this. I said it a lot today, don't I? This is going to be a good test. You thought the last test was good? This is going to kick its butt. Okay? Question, Kelly.
So if it can't be negative, can it still be x equals -3 or not?
Yeah.
From like the last one, like can be negative.
Okay, so we've got 3 numbers. So you're mixing up some concepts. You're combining concepts that you should not combine. Okay? So that's why I said there's 3 factors here. Okay? If you were to graph this, that's y equals x, right? That looks like a diagonal line, correct? If you were to factor this, that's a diagonal line also up 3, right?
Okay.
If you were to factor this, it would look like that. Okay? Now, in this case, I can get a 0. And I can get a 0 here at -3. Ain't no way I can get a 0 there.
Okay,
Okay?
that makes sense.
All right. Any other questions? All right. Now, by the way, what do any of these graphs, is that what this graph would look like?
No.
No, these are the domains I'm graphing. Okay? So, yeah, don't mix up the domain with the actual graph. This one is going to be a fun one, I can tell. Log of x squared plus 1 equals the log of x minus 2 plus the log of x plus 3. I've already handed out all the easy questions.
them all on one side.
Put them all on one side. You could, I don't think that would make it easier though. Angel, you got an idea?
Might be wrong, but I would just, well, this part isn't wrong. You put on the right side log of x minus 2 times x plus 3.
Oh, that's a good idea. So you're going to combine this into a single logarithm.
Yeah.
Okay, so this becomes the log of what again?
X minus 2
X minus 2
times x plus
x
3.
plus 3.
Would you multiply it out, or would you leave it like that?
Let's leave it like that for now. Okay, so all we did was we combined that into a single logarithm. This side stays the same, x squared plus 1. Okay.
How we've been just logging both sides, I would assume you could just take off the log.
So we want to do the anti-log, right? What's the anti-log of this? What's your base?
10.
Base 10, okay. So one way to think of it is, well, the anti-log would be just to put that in the exponent now. This is 10 to that, right? Because then that's going to wipe out that.
Oh, yeah.
And I'm left with x squared plus 1 equals, maybe I should boil that up now. That equals, do you want to tag it back to Ethan?
Sure.
Since you let him off the hook? What do you think, Ethan? Can you FOIL that out for me? X squared. Here, let's go slow. I think you said the right answer, but we'll go slow. We're doing the outside, so that's plus 3x. The inside is minus 2x. And then the last is -6, okay? So that does combine into be a single plus x, right? Okay, so you were right, okay? Now what? Okay, here I'll rewrite that. X squared plus 1 equals x squared plus x minus 6. How do we solve this? Subtract the x squared, goes away. It also goes away. So 1 equals x minus 6. Add the 6. X equals 7. Do you believe that's the correct answer? Here's one of the things that I'm going to caution you on. You really want to check your answers here, because you may get an answer here, and then when you plug it back in, it doesn't work. Okay? So I'm not going to circle this yet till I know that it's correct. Okay? So let's make sure. So the log of 7 squared is 49 plus 1 is 50, right? Log of 50. Does that equal the log of 7 minus 2 is 5 plus the log of 7 plus 3? 10. Are those equal?
10 times 5.
Yes.
Because we can combine these. Now you're seeing why we want to combine those. Log of 50 equals the log of 5 times 10, which is 50. So yes, that is a correct answer. Okay? So I even got an applause on that. That's good. Okay? So you really should check your answers, because you may get something here, and then you might get like a negative number here or something, and be like, oh dang, it doesn't work.
So,
What do you do if it doesn't work?
yeah.
And they said there's no solution.
Oh, doubt.
And you can do like tell if it's like, it might be that to do also.
Yeah, you really, so more than ever, really check your answers, because once in a while you'll get an answer and you'll be like, oh, but it doesn't work.
It just means no solution. It's good.
It means no solution.
Done. All right.
Okay?
I guess at that point, you're done either way.
All right. Yeah, so all that stuff we learned on last test is so that you can combine it all and never forget it for this section. kind of the nice thing about having a test every week is a lot of you would like to flush those logarithms, right? But you can't, you gotta keep it, okay? All right, how about the ln of x equals 8? Whose turn is it now? It must be Spencer's turn. How would you solve that?
So naturally, I want to say that it's e to the 8th power equals x, but I don't know.
So you're going to rewrite that as
Yeah.
e to the 8th power equals x. Wow,
Is that all you can do then?
that's the answer right there.
Oh, wow.
You plug it in your calculator. Okay. Wow, I didn't know you could do that much stuff, but good job. How about this one? Log base 2 of 25 minus x equals 3. You should pick on people who are using their phones during class, like Dino or Christian. I already picked on them both, and they thought they were safe. Maybe I should pick on them again. You guys want to tag team on that one? Christian goes, all right, Dino, save me.
So, I do the log first.
How do we do that?
If it's to the, if it's to the base of 2, can you still put the base of 10 and cancel out or no?
Base 10? 2. Yeah, I can't use base 10 because it's not the same base.
We square both sides.
If you square both sides, you could, and that would be horrible. Jackson did have a good suggestion. Did you hear what he said? You want to tag Jackson?
Only to the base, right?
To the base, so I'm
To the base,
going to draw a big 2, right? Because then I'll put a big 2 here, and then that will go away, right?
Yes.
Okay, and so therefore I'm left with
25 minus x equals 6.
2 to the 3rd power, which is 8, right?
Yeah.
Okay, and then what?
And then just subtract.
Take it away, Dino. You've been coasting on their coattails.
Add x, right?
You could, but I think it would be better to subtract 25. 25. So negative x equals
Right now.
pressure's on. 25 minus 8 is
It's negative
17. I don't know how to do that without a calculator. Okay, and then multiply by negative 1, x equals 17. Do you think that's the right answer? Oh, we better check our answer, right? Okay, can you check it, do you know? Is the log base 2 of 25 minus 17 equal to 3? 25 minus 17 is log base 2 of 8. Does that equal 3?
Yes.
2 to the 3rd equals 8, yes it does. Okay? These are going to be some good problems, right?
So the way that I kind of try to go ahead, so the way I did it is I did a little switch around like we did with the previous one. And I've noticed that we've put a 2 in front or a 10 in front of the 10. Does that, like, would you recommend doing that?
What did you do?
So you like the first one, the ln x equals to 8.
Right.
We just pulled down the x, set that equal to the base, to the.
Yeah, this is base E, right?
Yeah, so that little switch around.
Yeah, so you said, okay, well, I'm gonna rewrite this. Yeah, I mean, that's basically what I did. But we're using base 2 this time, right?
Yeah, but I've seen repeatedly we put like a 2 before the log. Essentially, we use like the other rule, which is if a number is raised to that log.
Yeah, that's what we're doing. That's exactly what we're doing.
Or would you recommend doing that
I would.
as opposed to?
So that's the best practice for this section.
Yeah, so the rule that you're talking about is, remember, the log, so a to the log base a of x equals x.
Yeah.
That's the rule you're talking about, right?
Yeah, but I'm just doing the log
So,
of x is equal to something else.
yeah, you're doing the same thing I'm doing. So,
Just want to make sure
keep
it's
doing
not
what
like
you're
that.
doing. Yeah.
All right.
Okay? All right,
Yes.
Well, I just, instead of saying 2, I just said, oh, 2 to the third is equal to the exponent.
Oh, you're using that, you're switching back and forth.
Yeah.
yeah, you're
I
switching
get
into
that.
exponential form, yeah, that's basically the same thing. Okay? All right, here's another one.
Yeah, so you're not.
4 plus 3 log of 2x equals 16.
What the?
Cameron, I think it's your turn. What do you think? I wanted to pick on Bailey, but she volunteered first. She's glad that you're saving her. Except for you can chip in if you want. What do you think?
Good, well, can we take out the base 10 out of that to cancel the,
Well, you can, but this plus is in the way. So you gotta get that. So if you want to do that, you gotta get rid of everything except for the log.
okay, so you subtract 4 from both
Subtract
sides.
4. So I get 3 log of 2x equals what? Are you using calculator for that?
And then,
We need to go back to the days of no calculators.
yeah, divide by 3.
Divide by 3, okay, that's good. Divide by 3 log of 2x equals,
Oh, I accidentally.
oh, no calculator this time, that's good. Okay?
Almost. And
When
then,
you doing it when we're backwards turn?
no,
Oh, yeah.
it still says 12.
Okay.
So then you can take the base 10 out, right?
Yeah, so we're gonna do the anti-log, right?
Yeah.
So that means we'll place them both there, okay? So then this is gonna wipe that out, and we're gonna be left with 2x equals 10 to the 4th, or a 1 with 4 zeros, correct? Okay? And then
Divide by 2.
divide by 2, dang. X equals 5 grand.
Wow,
You believe that's the correct answer?
blows your mind.
Do you feel good about checking it?
Let's go.
Let's check it. I'm gonna circle it because I feel really good about it, but we should check it first. Okay? So 4 plus 3 times the log of 2 times 5,000, does that equal 16? Sure. What is 2 times 5,000? 10,000. What's the log of 10,000?
Count the zeros. 3?
Count the zeros. We've got 4 zeros though,
Oh, 4.
because 2 times 5 is 10, right?
Oh, yeah, so.
So that's 4. 4 times 3 is 12 plus 4, 16. How about it? Who feels really smart right now? Okay, that's good. Okay, that's better than feeling the other way, right? Okay?
Let's
All
take
right.
a test.
Let's take the test. Bring it on. All right, let's do this one.
Just right.
Double.
I like that.
We're barely on the screen. Okay, how about this one? Look like, I guess.
It's just like pushing puzzles.
Now, by the way, some of these, I noticed on some of these examples that says solve them graphically. I think that's a horrible way to solve any problem. I only care about algebra. I don't care about solving these graphically in this section, okay? I do want you to know how to graph, but finding an exact answer with a graph is not a smart idea. Log of x plus 2 plus the log of x minus 1 equals 1. This one says solve it graphically, no, just solve it algebraically. Jonathan, I haven't picked on you. I think I'm getting ready to pick on everybody. We're gonna have to go back to beta now.
So we could bring those into one.
Bring those into one log, very well done. So this becomes the log of
X plus 2 times x minus 1.
x minus 1 equals 1, okay?
And then we could just use the 10 to cancel the log.
We're gonna do the anti-log, right?
Yeah.
What's the base?
10.
Base is 10, so that'll go away, and this becomes 10 to the first power, correct? Okay, so let's FOIL that out. That's gonna equal 10.
X squared plus x minus 2.
Minus 2, you just went straight. Okay, now what?
Subtract the 2.
Subtract the 2? No. I mean, you could, it wouldn't help.
Yeah. We just subtract it.
It's technically not wrong, but it's not helpful.
You can take, just move the 10 over, so it's
Move the 10 over, very good. Because you want to set it equal to 0. X squared plus x minus 12 equals 0. Factors in 2.
x,
X and x.
then be 4 and 3.
4 and 3
Plus 4 minus 2.
plus 4 minus 3. So x equals
-4
or positive 3. Now this is definitely one because this is definitely one you want to check because -4 might make one of these logs negative and I can't have that, right? This is definitely one you want to check, okay? So let's check it. So -4, so we're going back up to here. -4 plus 2 is?
-2.
It's -2. Can I find the log of -2? Can't be the correct answer. I don't even need to keep checking. All right. How about the 3? 3 plus 2?
5.
Log of 5 plus 3 minus 1?
2.
Log of 2. Does that equal 1?
Yes. Because it's log of 5 times 2.
Yeah, we could rewrite that as the log of 5 times 2, which is 10. Log of 10 equals 1. Okay, so definitely need to check your answers because we get to throw out one of those. Okay? Finally found one. Okay? How about this one? X squared equals 2 ln of x plus 2. What do you think, Nate?
Squared equals 2. So we would need to divide x squared by 2.
Okay, so we need to get rid of the 2.
Yeah.
So x squared over 2 equals the ln of x plus 2.
Yeah. Then we need to get rid of the ln.
How do we get rid of the ln?
We change the base to e, or
We're going to do the anti-logarithm of the e, which is basically e to that, right?
yeah.
So that's going to wipe that out.
So that'd be e x squared divided by 2 equals x plus 2.
Then you subtract the 2.
So now I got x equals e to the x squared over 2 minus 2, but I've got x's on both sides, right?
Yeah.
That's a problem. What do you think?
To help this square both sides at all.
No, it's going to make it worse. That was a good guess. I would have probably done the same thing, but we're in big trouble now, aren't we?
Yeah.
Should we start over?
Yeah.
Okay, let's start over. All right, let's see. So that didn't work. I'm going to rewrite the problem over here. So the original problem was x squared equals 2 ln of x minus x plus 2. What do you think?
You move the 2 to the x plus 2 squared. And that
Oh, you know what?
I did that last time.
Guess I should have looked ahead on this one. Yeah, this one you have to solve graphically. We're not going to do that.
Yes. Scribble this one.
Yeah, never mind. I won't give you that one. Yeah, this one you're going to have to use a graph to get some approximate solutions. We don't have any methods for that. All right. Okay. So it must be time to do some interest problems. All right. Yeah. Okay, what if I said, what if I had an equation, 1 over k times the ln of I over I naught equals x, and I said, solve for letter I.
What's I not?
A number.
I with a 0.
All these represent numbers.
Is it different than I?
All I care about is it's the formula and I want you to solve for a specific letter. Okay? So, who haven't I picked on? Everybody? I think I have. It must be Bailey's turn.
I'm just gonna give it a go because I really have no idea what I'm doing.
Okay? We want to get this all by itself. That's the goal.
Okay, so should we get rid of the negative 1 over 3?
How do I get rid of that?
We multiply it by the reciprocal. It's okay.
Negative k, right? Negative k over 1, right? Those will cancel. Okay? So that means they're going to multiply this by negative k. Sorry, I wrote that wrong. Negative k. Okay? So this becomes the ln of I over I naught equals negative xk, correct? Okay, good first step.
Then we multiply both sides by e.
What'd you say?
Multiply both sides by e.
We're not multiplying by e, we're doing the anti-logarithm. Which one way you can think of that is to put a giant e and put that in the exponent, right?
Yeah.
So that's going to become I over I naught equals
Just e to the
e to the negative xk.
then we would multiply by I over
I naught, right? So those will cancel, and I'm going to multiply that by I naught. So I equals I naught e to the minus xk.
So is that right?
That is correct.
Okay, sweet.
You gonna ace my test?
Yes, I hope so. I
Okay.
really need to.
These are good, aren't they? All right.
Why not?
What is I naught? Well, so let's say that this is the equation for the transparency of the lake, known as the Beer-Lambert law. So let's suppose that K equals 0.025 and I naught equals 14 lumens. And find the light intensity at 20 feet. Have any of you ever been scuba diving? Who's a scuba diver? Any of you?
Got once.
You gone once? Anybody else? So the reason I'm bringing this up is because you know when you scuba dive, although even if you haven't scuba dived, you know it gets darker the deeper you go down, right? So the idea here is, how much light? They measure light in lumens, okay? So how much light would you be down? Would you have? How many lumens would you have at 20 feet? Okay. Now, funny story. I've been a scuba diver for a very long time. 19 years ago, I married my wife. We went on a honeymoon, and we went on a cruise to the Caribbean, which was just fabulous. I highly recommend that if you're not married, okay? On the cruise ship, they said, oh, we can do a scuba diving lesson on the cruise ship in the pool. And so my wife was like, oh, let's do that. Let's try that. She freaked out, which I'd rather have her freaking out in the pool than under the water. So all my married life, I've been married for 19 years, I haven't been able to dive with her. And she said, well, one day we'll have a child, and maybe that child will go with you. So this summer, my 16-year-old son, he's now 17, she said, hey, why don't we get Brandon scuba diving, and you can go on and dive together. So we went to the Bahamas. It's great. So that's where we went on our honeymoon. It was great. So she books the dive. We get there. It takes a half hour to drive from the cruise ship to the dive place. And as we're getting off the bus, they said, oh, by the way, we're going to see some sharks. Does that bother anybody? I have never seen so many sharks in my life. Most of them were like 4 foot long. I mean, but I did see one that was about 8 foot. And I was like, hey, it was my son's very first dive. I get out of the water, I'm like, oh my gosh, I've never seen so many sharks in my life. And he's like, what? That's normal. So anyway, but it is darker with that little tangent there. It is darker under the water. That's what this equation is for. So, Hunter, now that you know all that, plus the shark story, how much light can you see at 20 feet deep? Just plug it into the equation, right? So I is the answer we're looking for, equals what? What's I naught? 14 lumens. E to the minus. What's x?
Is that 20?
20 feet.
Oh, yeah. 20.
Times K, which is 0.025. And as everybody knows, the answer is 8.49 approximately lumens, which means it's about almost half as light as it was at the surface. Okay? And so you know when you go and you see all those National Geographic things and all those fish are so colorful, you know they've color enhanced that, right? That's not what it looks like underwater. because it's really kind of dingy because they don't have as much light. Okay?
So I naught is to signify original light source.
Yes. In this case, yeah, it's your original light source at the surface.
So is I naught I to the base 0?
No, it is not I to the base 0. It's
What is
just,
what is the naught
it's just to differentiate between this I. It's a specific value of lumens. It's just a constant. So if you take physics, you'll see this a lot, this kind of notation a lot. So typically, or even statistics, this just represents some initial value, usually. Okay? All right. All right, let's do one more problem here, and then we'll move on to the next section. I joked with my wife after we got back to the cruise ship. I said, "Did you know that was a shark bite?" She looked at it, wasn't me. She said, "No." And I said, "Are you trying to get rid of me or what?" So anyway, the sum of $5,000 at 5% per year is invested. How long until it doubles if you compound semi-annually or continuously? Okay, how would you solve that one? Caitlin, it must be your turn.
All right. Okay, so is that 500 per year? Is that what you have?
It's $5,000 at 5% per year.
How long until it doubles? So semi-annually you would have 5,000 parentheses 1 plus, so the rate is 0.05 over 2. Then you would have the 2 and the 1 year, right? Or
Well, it's NT. You don't know how many years it is. Yes. But if it doubles, how much are you going to have?
Wait, no, sorry, it doubles.
How much did you start with?
So you're starting with 5,000.
And if you double that? 10,000. Okay. So then,
So now we solve for t.
solve for t.
So divide by 5,000.
Divide by 5,000. So this becomes 2 equals 1 plus 0.05 over 2 to the 2t power.
And then would you do the log? So you do the log to both sides.
Okay, base 10?
Yeah, base 10.
Okay, so we're going to take base 10 logs.
So then you
This is
move
going
that
to come
to
out
the front.
front. So log of 2 equals
Log
2t
2t. Okay, so this
Log.
is log 1 plus
1 plus 0.025. We'll just actually get rid of the plus. It's 1.025.
Okay.
Okay?
And so then you would divide the log base 10 by 2t.
So divide by 2's and the log of 1.025. Okay, so we're only left with a t here, correct?
Yeah, yeah.
So that means I'm going to divide by 2 times the log of 1.025.
Okay, cool. So you can do that all.
And as everybody knows, that equals 14.04 years. You can't do that in your head? What's wrong with you? Did I tell you about the movie called Pi? Did I ever tell you about that movie? Not Life of Pi, that's much better. It's just called Pi. Okay? It was the first movie ever made on DVD, and I'm sad to say that I watched it. Okay? My friend told me, hey, you like math? This is a mathematical thriller. And I said, those two words don't go together. So anyway, who wants to watch it? Somebody told me they watched it and they were like, oh, that was a great movie. I'm like, that movie sucked. So here's the story. You want me to do the spoiler for you?
Yes.
Okay. For some reason, even though it was the first movie made on DVD, they shot it in black and white. I don't know why. I think it was more suspenseful or something. I'm not sure. So there's this guy. If you said, hey, what's 5,287 times 364 or something, he would be like, it is whatever the answer is. Like super. Some people can do that in their head. I don't know how to do that. But anyway. So he was this super smart mathematician guy. This is really weird movie. So these guys, so he wanted to solve the stock market not because he wanted to be rich or anything, like who would do such a stupid thing as that? Just because it was a good math problem, okay? Well, it turns out that whatever this number is the name of God.
What the crap?
And so all these Orthodox Jews wanted to know what the name of God was. Okay? So he's got all these Orthodox Jews that are chasing him down because they want to know the name of God. And then they have all these stockbrokers that are chasing him down because they want to make money on the stock market. And so you know how he saves mankind? I'm gonna spoil the movie for you. He takes a drill and he drills his head.
What the crap?
Yeah, it's a great movie. And then it's a mathematical thriller. And then
The name of God is a number based on the stock market?
yeah,
Wow.
isn't that amazing? That's a great premise, isn't it?
Yeah, dang.
Yeah, who knew? So anyway, at the end of the movie, he survives after drilling himself in the head. And they say, 492 times 3,608. And he goes, I don't know. Seriously, dumb movie.
I think we should watch it.
We should watch it. Go watch it. You might like it.
Yeah.
So, rather than deal with that, I don't know why I told you that story, but it was a great story. Okay, so you guys remember. Okay, you guys everybody remember, we're on to 4.6, which is exponential functions, which includes exponential growth, correct? Okay, they've got a formula in here, but you all remember the formula A equals PERT, right? Yeah. That's an easy formula to remember. Okay, don't memorize all these other formulas, it's the same thing. Okay, A equals PERT, that's all you need to know for this entire section, I think, for most of the section. Anyway, we're going to apply this formula, A equals PERT, to this equation. Bacteria culture has 500 organisms. Biologist finds growth rate is 40% per hour. Find a function that models this growth. Okay, and I'm going to tell you that all I want you to do is use A equals PERT. Okay? So if we use A equals PERT, if we were to apply this, if we were to think of this as principal that you would invest in a bank, what do you think, Julia, the principal would be in this case? Okay, I want you to use this equation here, A equals PERT. P usually stands for principal, right? Like how much money you're going to invest.
Okay.
In this problem, what would be the principal?
500.
500. Oh, it helps if I, you guys are terrible at telling me it's off camera.
Sorry.
Okay, A equals 500. E to the, what do you think the R is?
40%.
0.40, right? And your T is your time. This time, instead of in years, we're doing it in hours. Okay? So this is now, if I change this to functional notation, what is this a function of? There's no x in the equation. It's a function of t, so A of t. You just came up with a function that models this growth. A equals PERT. Okay? Does that make sense? Part B, what is the count in 10 hours? So, whose turn is it now? It must be Hunter's turn.
You just plug in.
I haven't picked on everybody twice.
Plug in 10.
Plug the 10 in, so A of 10, right?
Yeah.
Equals
500.
500 E to the 0.40 times 10, right? And as everybody knows, because they're a math magician, and they can do that in their head. Oh, that's why I said that. I told you that story about pi. Now I remember what the story was. That is a mere 27,300 bacteria. That's a lot of bacteria. Okay? Now, part C, we're still on here. A little more on board. When will the population reach 80,000? Must be Victor's turn.
Do you rewrite it? The 80,000 for the A?
80,000 for the A equals
500 E.
500 E
0.40 times
0.40 times
T.
T. You solve that equation.
You divide by 500.
Divide by 500. So two of those zeros will cancel two of those, and then I'll divide by 5. 800 divided by 5 is 160, I believe. Who needs a calculator? E to the 0.4T.
And then you take the ln.
Take the ln of both sides. ln, that's going to go away. So I'm going to get the ln at 160 equals
0.4 times T.
0.4 times T.
Then you divide by 0.4.
Divide by 0.4. And as everybody knows, that answer is 12.68 what? Hours. Okay? This isn't too bad. Okay, they've got some other dumb formula, but it's the same thing. All right, let's pick a different topic like radioactive decay. Okay. Polonium-210 has a half-life of 140 days. Suppose you have 300 milligrams. Find a function that models this. Okay. So, what must be your time? What does half-life mean? Do you know that?
So after 140 days,
How much will we have left? Half of that, which would be 150. 140 more days, you'll have 75. 140 more days, so, yeah, 37 and a half, okay? All right, so this stuff seems like it takes forever. I'm trying to remember if this is the stuff. Do you guys remember, gosh, it's probably been 4 or 5 years, some guy got poisoned by the Russians. I think it was polonium-210. It might have been something else, but something highly radioactive killed him. Or did it just make him sick? I think they've killed one person and the other guy was really sick. Yeah, there was a guy and his daughter, he got poisoned in UK. It's crazy. So, how would you find a function? Our principal is going to be 300, right? E to the
rate is 0.5 times.
Well, we don't know what the rate is, but we do know the time.
Yeah, time is every 140 days.
In 140 days, how much will we have left? We'll have 150 grams left. So we could actually solve for R, correct? Okay, how would you solve for R?
Just take the ln, or I would divide by 300 actually.
Divide by 300 first. And then this is going to be 0.5 equals e to the 140R, correct?
Wait, sorry, where'd you get 150?
Where do they get 150 from? That's your half-life.
1/2.
In 140 days, you're going to have half left. We started with 300. We're going to have half left in 140 days. So I'm trying to figure out the rate. I didn't tell you what.
We're just trying to figure out the rate.
Yeah. Okay? Because we're trying to figure out what this function will be. Okay? So now what?
And you can take the log.
Now I can take the log of both sides. The ln of 0.5 equals 140R, correct? And then
R is equal to ln 0.5 over 40.
okay, so R equals the ln of 0.5 over 140. Okay, so now we need that in order to find the function that models this. Okay, now they give you another formula, but I'm trying to help you not remember a bunch of formulas. Because this is A equals PERT is pretty easy. So if I do A as some function of time, time is going to be measured in days in this case, okay? What's the function going to be? 300
Times
E to the R. R is this number here, correct? And I would just leave it just like this. You can put it as a decimal, but just leave it like this. E to the ln of 0.5 over 140 times t for time. This is just using A equals PERT. So we're still using A equals PERT, okay? So this is the function that you just figured out because you knew that we were dealing with half-life. Now the book has a second function. You're welcome to memorize it. I don't like to memorize stuff when I know that it's just the same thing as this formula, A equals PERT. Okay? But if you want to use it, you can. I'm just trying to get you to avoid using it.
Scientifically, wouldn't you just leave the 300 as a variable, and t would be a fixed? And so it would just be A of t is equal to whatever 300 represents. E.
300 represents the initial amount you have.
300, so you have to keep that there.
We're still trying to figure out how much you're gonna have in 50 days or 100 days or whatever. I mean, the scary thing about that spy thing was they found, it seems like, I'm trying to remember, it was a man and his daughter that got infected by this stuff. And then like days later, somebody was in the area and then they got sick. Because this is bad stuff.
What's the function they give? Just
What say it again?
like, or what's the equation they give for half-lives in the book? Just if we want to memorize it.
If you want to memorize it, they change all the variables and they say m of t equals your initial amount, m sub 0, 2 to the minus t over h.
All right.
If you want to memorize that and knock yourselves out, then it's just a equals per. And you can figure out half-life.
2 to the negative t times h.
Yeah. It's not worth it to me, but whatever. I'm trying to remember, I didn't look in here. I can't remember if I gave you a Newton's law of cooling.
That doesn't sound familiar.
No, I'm talking about the homework. Here, you might not have a homework problem like this, but I forgot to write in my book which problems I assigned. So I'm going to do this one just in case. You may or may not have a problem similar to this. But it'll be good practice either way. So Newton's law of cooling. So I was talking to this guy and he said Isaac Newton was really brilliant, but he was freaking weird in his personal life. So I did not know that. But anyway, here's the formula. Capital T of little t equals T sub s plus, and they use D0 e to the minus kt. Do you see that that's just pert right there? It's essentially pert, okay? Now, D0 is the initial temperature.
Is that not D naught? Is that different?
D naught, same thing. D sub 0, D naught. Sorry, it's the initial temperature difference between an object and its surroundings. T sub s equals the surrounding temperature into lowercase s. Yeah. T sub s is surrounding temperature. Time is t, and that can be measured in days, hours, whatever you want it to be. And k is a constant depending on the object. Okay? So, here's your Newton's law of cooling. Those are all your definitions. So let's say, for example, that a cup of coffee has a temperature of 200 degrees Fahrenheit, to which I say, what in the heck are you doing, McDonald's? It shouldn't, that'll burn you. You guys should see that documentary. You remember the woman who got burned really bad in Sue's McDonald's? She had like third-degree burns. It was bad. So anyway, I'll give you a different idea. You should watch it. It's on Netflix. The room temperature is 70 degrees Fahrenheit. After 70 degrees. After 10 minutes, the coffee is 150 degrees Fahrenheit. Find a function that models the temperature. Okay. All right, whose turn is it? Niels, it must be your turn.
Let's do it. All right, so we're looking for T.
T of T equals
It's going to be the surrounding temperature, so it's going to be 70.
is the difference between the object and its surroundings.
I was just plugging it into the formula. So would we not plug in 70 for TS?
You would not plug in 70.
Surrounding.
So it's the difference between the object. So the object is 200, the room temperature is 70,
So 130.
so it's going to be 130.
Okay.
Plus,
The initial, which would be of the object.
oh, sorry.
Yeah, I was gonna say.
Oh, no, I
isn't
mixed,
TMS
you had it right. I mixed up. This is the 130. You were right. This is 70.
All right. So we got 70 plus 130.
Okay.
And then we do E
E.
to the negative,
Negative K. We don't know what it is yet, right?
that's what we're
We don't know what our constant is.
and then the time is after 10 minutes.
Time is
So
10 minutes, so this is going to be measured in minutes. Okay, so we need to figure out what is K.
Can we,
So what is this answer here? After 10 minutes, the coffee is still going to burn you at,
after 10 minutes, the coffee is 150.
150. Okay,
So minus 70.
subtract 70. 80 equals 130 e to the minus 10k, right?
Then we're going to divide by 130.
Okay,
8/13
8/13 equals
e to the
minus
negative
10k.
We're going to do the natural log of both
Natural
sides.
log, it's going to go away. ln of 8/13 equals minus 10k.
Divide by negative 10k.
Divide by
or
negative 10. So k equals ln of 8/13 over negative 10. Okay, so your function is going to be t of t equals
I'm not sure what you're asking.
I'm just asking you to plug in, now that we know what k is, we're going to plug it into here.
Oh, okay.
So t of s is, t sub s,
It's going to be the 70
70
plus
plus
130
130
e to the
e
negative.
to that, this nasty thing here,
Yeah.
times t. Okay? All right, and then when will coffee be 100 degrees Fahrenheit? Now, I will just mention, we're kind of out of time, but how would you solve it?
Well, you plug in
100
into the
right
front.
in there, and then just solve it. Okay?
Into the
Now, do you know what this Newton's law of cooling is often used as besides coffee? Like, what's a real life application? If you find a dead body in a room and it's at 60 degrees or whatever it is, when did the body die? Yeah.
Death.
What was the time of death? Yeah. Now, of course, if it's been there for 3 weeks, it doesn't help it, but if it's been, if it's just been a few hours, You can figure out the time of death. Okay? So, quiz tomorrow, 4.5, 4.6. I think we're going to move on to chapter 5 tomorrow. So, see you all tomorrow.
So, no more logarithm.
I don't know.
Chapter 5 more?
It's chapter 5. What's chapter 5?
Oh, I don't know.
Sorry.
Oh, yeah, I think, yeah.
More logarithms or we're done?
Nope, systems and equations.
So,
we won't be as bad. But just remember, all those questions you missed, I might put back on the test again.
Right.
Well, 3 of the questions we'll know.
Most missed?
I only put on one last time, didn't I? Actually?
So you put 2.
What was the other one?
You put the,
The synthetic division one.
yeah, you put the synthetic
Yeah,
division and
I thought you had the fraction.
No, we didn't.
Yeah, I was gonna put the derivative on there and I didn't.
I thought you were gonna do a combo of the fraction one, the x slope formula, but like have it 10 to the x power, like under 1 or something. I thought you were gonna do something like
I
that.
was thinking about it.